This is Education Arena presenting a brand new series, What If? And this is the first of its kind, puzzling out the grandfather paradox. Einstein's theory of relativity inspired scientists from around the world to begin imagining that time travel is theoretically possible. Imagine for a second that time travel became completely possible in practice. Suppose you decide to go back in time, for example, to meet your grandfather whom you've never met. You know the exact time and place where your younger grandfather was in the past, and you go there. Since you have entered the exact coordinates of his location, the time machine lands right on your unsuspecting grandfather and crosses him to death. It turns out that now your grandfather does not meet your grandmother, which means that one of your parents won't be born and neither will you. But here's the twist. If you didn't come into the world, then you couldn't possibly go back in time and kill your grandfather. Thus, we see how the paradox turns out. Physicists call it the grandfather paradox. Many scholars use it as an argument against possibility of time travel to the past. So, what's the solution to the paradox? But first of all, how would you travel back in time? According to Stephen Hawking, one can travel in time with the deformation of space-time. If this occurs, a so-called wormhole is formed, the original space tunnel. Moreover, you can move both toward the past and the future. It all depends on the type of wormhole itself. To visualize how it works, draw two dots on a piece of paper. There would be some distance between them, which would take some time to cover. But we want to deceive time, so let's play a little trick. Folding the sheet in half, you'll see how the 2 points of space connect. The distance between them will be unnoticeable and can be covered in a split second. This is how wormholes work according to the theory of relativity. It would seem that everything is quite simple, but it lacks one important detail: exotic matter. Before wormhole can be used, it has to be filled with this substance so you can enter from one end and exit from the other. In the absence of such matter, the portal through space and time will slam shut even before you have time to move from one end to the other. This type of matter is still unknown to the modern scientists, but we can roughly assume how a time machine based on wormhole would work. For a successful journey, one end of the wormhole must be accelerated to near light speed and then returned to its original state. Sounds pretty complicated. That is why even the greatest minds of modern science can't create anything like this. Surprisingly, such temporary tunnels don't contradict the laws of physics, but for now in space, there isn't a single confirmed candidate for this role. But for the sake of curiosity, let's assume that you've found and examined one such wormhole with exotic matter, making it possible for time travel. As per the title, you go back in time and beyond the dire consequences, you try and kill your grandfather. You might return to your time and find that your family, home, and all the traces of your existence are gone. But if so, have a look at this picture of the paradox. So if you're born, you create a time machine, go back into the past, kill your grandfather, then your father won't be born, and consequently you won't be born to create a time machine and go back into the past. Ultimately, your grandfather's alive, and so the paradox continues in a cycle of events and you're trapped in it. So what's the solution to the grandfather paradox? Fortunately, such a solution exists, thanks to the research in the behavior of light. Back in 1803, when scientists were arguing what light waves or light particles are, Thomas Young put an end to this discussion. He conducted an experiment in which he exposed a beam of light through an opaque screen with two slits. It was expected that the two parallel lines of light would come out through the holes, but the light passed through the slits like a wave. Then other researchers decided to repeat the same experiment, but not with a whole beam of light, rather with a single beam of electron. It was assumed that the electron would pass through one of the two holes, but in astonishment of the scientists, it simultaneously made its way through both the slits. Thus, scientists discovered quantum mechanics, in which an electron is both a particle and a wave. Hugh Everett proposed the theory of multi-world interpretation, according to which the universe is divided into two worlds, one world in which the electron passes into the first gap, and a second world where it slides through the other gap. This has a direct bearing in the case of the grandfather paradox. According to Everett's theory, after your grandfather's death, you have created an alternate universe in which your grandfather dies after being crushed by a time machine. But in the original world, nothing has happened. Your grandfather is alive and well. You could still have been born, after which you travel back in time and divided the universe in two. In this way, you wouldn't be stuck in the time paradox, aka ontological paradox or time trap. Still, time travel might not be possible because when you pass through the wormhole, you will be struck by an endless impulse of energy that will erase your entire past. However, this can be avoided if the wormhole consists a special kind of exotic matter, as I said earlier, which means that talking about time travel is impossible, even in theory. But as experience shows, many theories mathematically deduced by Einstein are sooner or later confirmed in practice. What do you think? Let us know in the comments section. What if we discovered an anti-Earth? Well, that's a story for another What If.